write down some helpful tips in real life where you might use percents. So consumer applications of percents. Who can tell us what a consumer is? What do you think?
Someone who buys something?
Yep, someone who buys things. So a consumer is someone who needs to, nowadays, use money. In the old days they bartered, but use money basically. So it might be an item or it might be services or what have you. So one of the most common uses of percents is in the buying and selling of goods and services. Anyone have any idea of when you might use percents? If you're dealing with money? What do you got? Huh? Coupons. So in general, coupons are sales. A lot of times in the store they'll say sales, like things on this rack, if they have a blue tag, it's 20% off or something like that. Or you might have a coupon to bring to a store that has a certain percent off. So we summarize that with the word discounts, typically. So you might find percents when you're dealing with discounts. What else when you're dealing with money things might you need percents?
Taxes.
Tax. Now a lot of people go, oh, I'll just go to New Hampshire. No, you won't. You still have to pay tax for property tax, but also at restaurant. New Hampshire does have a meal tax. It's true. And speaking of meals, when else might you use percents? Maybe not as exact as we'll do in math class, but you kind of use percents a bit, maybe, perhaps. Like where? The tips. So those are the three big consumer applications of percents. Now discounts is when you're going to be saving money. So if you're trying to find your total after discount, that's subtraction. You're going to be paying less than what it originally cost. Versus tax and tip, when you have to add an amount on to, the sticker price, because you have to pay more for the tax, or you have to pay more if you're going to give a tip. And so we're going to focus on those particular skills. All right. So if a problem asks you to find out how much is saved, you compute the percent discount of the original price and round to the nearest hundredth. Because money goes to the cent, which is 100th of a dollar. And that's why a lot of times when I'm dealing with percent of a number in a money situation, I just use the decimal version of the percent, if it's not like an easy mental math type of scenario. Now if they ask you to find the bargain price, the discount has to get subtracted. So you might have a problem that says, what's the savings, blah, blah, blah. You just stop once you find the savings. But if it asks you to find the bargain price or the new price or the sale price or any of those kind of terminology, that's when you have to actually make sure you do the subtraction. To calculate a sale price after percent discount. Two ways you can go about it. You can first find the savings, then subtract it from the regular price. That's the part that seems the most intuitive. However, if you're in a real life situation and you're looking at something on a rack and it says it's $28, but everything on this rack is 15% off or something like that, you're not going to want to figure out 15% of 28, even if you have a calculator in your pocket because you have some sort of smartphone of some sort, and then have to figure out, oh, but I have to take that amount and subtract it from the 28. Because that's two steps, and you have to remember that middle step, and if you have two kids hanging out with you like I usually do, you don't have time to find a piece of paper, write down that middle step. So what I would do, I think it was a $28 item, 15% off, right? To do it with the calculator, just one step without having to think about a middle step, I go, okay, if I'm saving 15%, that means I'm paying how much? What percentage of the price am I paying if I'm saving 15%? Bless you. Yes, sir? 85%. 85%. So if I'm going to take out my cell phone and figure it out, I'm going to do 0.85 times 28. That's how much I would pay for that item if I wanted to know whether or not it's a good deal, whatever. So in real life, you can subtract the percentage amount, the percent discount from 100%, and find that percent of the price to see how much you have to pay. And then you don't have to worry about keeping track of the middle step. So we're going to show it both ways with this example here. So for the first one, well, they're both going to find the same answer to the example. Find the new price of a $275 item if you save 12% of the regular price. So if I wanted to find 12% of 275, I'm dealing with money, I'm probably gonna use my decimal form of the percent. Convert 12% into 0.12. And then go ahead and do that multiplication. No. So $33, that's the savings. If the question just said, how much would you save if there was a $275 item on sale for 12% off? If that was the question, we would stop right there. $33 is the savings, or is the discount. But if the problem had asked, like this one, what's the new price or what's the sale price, then we have to do the subtraction. So we have to subtract the discount from the original price. 275 minus 33. 5 minus 3, 7 minus 3, and 2 minus nothing. And we'd find that that item would be $242 after this 12% discount. So this one, a lot of times, if people are using this strategy to find the sale price, there was so much work involved with that first step that they go, whew, next problem, and they forget to do the subtraction. So don't fall into that trap. If they ask me for what's the total, this is a 12% savings. So the item used to cost me the full 100%, but instead I'm getting 12% off. So what percentage do I have to pay? What percent of the cost? 88%. So we're going to instead find 88% of the $275. So go ahead and do that computation. I get the same result, but with a different method. And again, that, I think the book might even call that the one-step method perhaps, but it's really 2 steps, but I'm just doing the subtraction up front instead of after the fact. So it just switched the order of the subtraction. Now some people are so used to needing to use percents for this reason, they accidentally subtract when they're trying to do tax and tip, or vice versa. So you've got to make sure you're paying attention to what the scenario is all about. So in the next section of the notes, it's going to be about situations where we need to add more to the original total. Keep scrolling. So if a problem asks you to find tax or tip, if it asks you to find the tax or tip amount, you compute the appropriate percent of the original price and round to the nearest hundredth. And again, that's because we need to go to the penny. Can't seem to get these fit in line because I'm not lining up my pen. And that would be it. What would be the tip you would leave for, you know, a such and such amount of bill if you want to leave 15% or 20% or 18%? What tax would you expect if the tax rate was the annoying 6.25% that we have in Massachusetts now? That would be it. But if it asks you what is the total, or what do you need to leave, or that sort of thing, then you have to do the addition as well. So if a problem asks you to find the total needed, the tax and or tip amount get added. So to calculate the total after tax tip, you could first find the tax and tip amount and then add it. Or again, we could deal with the whole, I was going to pay 100%, now I'm going to pay 106.25%. Gosh, that's an annoying tax amount. Or you can add the percent to 100% and find the percent of the price that you'll pay. So I will sometimes really want to be getting out of that Dollar Tree as soon as I get to the cash register, so I want to find out my exact amount. I'll sit there and I'll look in the cart and I'll be like, okay, I got 6 things, so $6, but I need to also pay the tax. Because Dollar Tree, it's in Tingsboro. Yeah. So I would sit there and I'd go, okay, and I take out my phone maybe, 106.25% is what I'm going to pay. And I have $6 items in my cart, so 1.06 0.0625 times 6, and then I round it, and I can have the exact change ready to give to the person, and they can get on out of there. So if it's the line and you have the time, you could figure out exact change to give to them. And again, without having a middle step, you could add it to the 100%. So the example we're going to look at is going to try to find the total you should leave to give an 18% tip on a $46.28 bill. Down here on the bottom, I wrote a little note. You wouldn't really go that precise. You would kind of just do a little estimating and rounding and stuff, but or you like do a quick tip app or whatever. If we were doing it very exact and precise, we could do 46.28 times 0.18 to find out what the amount of the tip would be, and then round it to a dollar amount, dollars and cents rather. Let's go ahead and do that computation. And then swoop, 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 swoop. We ignored 4 decimal places, so that we have to go 4 decimal places back in. So in American money, we don't have a thousandths coin or a 10,000th coin. We only go to the hundredth. So we have to round it to what? The amount of tip this waitstaff person is going to get from us is how much money? Because we're going to be so super precise. $8.33. That's the tip. If the question just said, what's going to be the tip, blah, 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 that would be our end. But if the question like this one says, what's the total, then we have to add it up. And on yours, I didn't have as much space, so you kind of got to squeeze it in. So go ahead and add $8.33 to $46.28. $54.61. That was a good meal. And again, that is when you find out the percent of the number and then do the addition, but you could find the addition beforehand. So I have to pay 100% because I have to pay for the meal. You can't, they don't like it when you don't pay for the meal. And I have to give an 18% tip on top of that. What percent of the bill am I going to be leaving for them? What's the total percentage-wise? Yes, sir?
118%.
118%. So I'm going to find out what 118% of $46.28 is. Who can tell me what 118% is as a decimal?
1.18.
1.18. So this is one of those scenarios where we're going to have a decimal bigger than 1 to do a percentage equivalency. So go ahead and try to multiply out the 46.28 bill times the 1.18 times the bill, the amount that I'm going to end up paying in total. Again, swoop, 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 swoop. We're going to round it to the nearest penny to get that same $54.61.